Okay, we continue with this lesson. The business content of IoT.
IIoT technologies are called as one of the primary drivers in Industry 4.0 because the enormous business opportunities that they bring in terms of how manufacturing companies can deploy these applications and create value for customers or manufacturers, suppliers, all the stakeholders in the manufacturing ecosystem. In fact, as we talked about, if you bring together high-speed connectivity and then embedded intelligence in these devices through software and also the ability to connect these devices and then build these applications on cloud platform, hence enabling this ubiquitous access, I think it just leaves imagination there's only limit in terms of what companies could do, putting all these capabilities to create applications that deliver business value. Now, we are, this segment will talk about maybe about 5 dimensions of how IIoT applications can deliver value to manufacturing, but these are just, starting point. These are just some, 5 dimensions. But beyond this, as I said, imagination is the limit in terms of how you can further build these applications. So, as you see in the chart, I've kind of captured, the 5 dimensions in terms of, benefits from IIoT applications in terms of improving the manufacturing productivity, in terms of improvements to quality, cycle time, and of course, safety and compliance. And last but not the least, the customer experience itself, right? Your IIoT applications can actually deliver in all these dimensions and more. We'll talk about it. So let's talk about productivity first, right? As I say, in these bullet points, basically with IoT applications, you can connect assets and processes to kind of dramatically improve the utilization of capacity, utilization of the assets. Let me give you an example, right? One of the large manufacturers in an emerging market, they had almost it's a mining and a cement manufacturer. They had almost 8,000 dumper trucks, in just one location, kind of one segment of the market, 8,000 dumper trucks in operations with multiple projects, and but at the same time, where they were actually kind of facing challenges that they were not optimally utilized. There'll be more trucks in the place where they're not actually needed, and there'll be they may not have the dumper trucks in the place where they really need it, right? So they just simply created an IoT application by tracking the movement of all these dumper trucks, right, and capturing and building this application to be accessible from cloud. So what does it do? Actually, it gives real-time visibility for all these trucks, and also they can through complex sensors, they can not only track the location of the loaders, but the dumpers, but they can also see how often are they used to full capacity or not. All these different kinds of information you can actually capture through these IoT applications. Now, when you put all these things together, then you can instead of some managers maybe could optimizing it locally in that particular unit. When they get information about capacity utilization of all these thousands of dumper trucks, they could actually then pool that in a common place and better allocate the resources. In other words, these applications allow you to reconfigure the resources so that you can improve the capacity utilization. Similarly, like you can actually kind of proactively identify some problems and say, for example, if there is a process in manufacturing sequentially, and through IoT applications, if you can actually sense maybe a deviation of a particular machine, an upstream process, then you can actually, if you catch that error, then what you've avoided is that those kind of parts being moving in the downstream with that quality problem. So it kind of both attacks your quality benefits and of course reduces the rework and comes back to your productivity benefits as well. So going to the quality now, we just talked about some of the quality benefits, but in quality, IoT sensors application, they can actually kind of they can limit the manual intervention, right? In fact, a lot of times there are machines that actually kind of precision is very important, and sometimes when there is manual intervention, there's automation of some of these processes can actually kind of either completely eliminate manual intervention or they can guide the manual intervention so that your reliability goes up and the possibility of error comes down. Sometimes the machines are calibrated and in a way that you can actually you can get the real-time process operating metrics, right? I mean, it is often called the PQ charts in manufacturing context, where the parameters under which the process of a machine operating should be within that range. And if there is any range that is actually deviating from that, then you can have IoT application that can capture that information at a central location. They can immediately the manager, she can take an action either to stop the line or make any corrective action so that there's no downstream kind of wasting of resources, and hence that will actually improve both not only the quality but also productivity and cycle time as well. Again, in the context of cycle time, you can if you can anticipate problems, then of course you're reducing the rework and the overall cycle time gets reduced. You can again you can take this not just within your own factory, you can actually take it beyond your factory in the upstream suppliers as well. Sometimes in a hyperscaling cloud architecture, some large manufacturers even actually mandate that some other suppliers connect to their IoT platforms and provide real-time information into that IoT platform what's happening in the supplier operations, or when is this the next dispatch going to be happening, or if any quality problems in the supplier operations. If they get to know that information proactively, then obviously they don't have to block some of the resources for that defect part that is coming in, because that's going to be stopped now, it's going to be rerouted. So they can now deploy these resources in a different place and then improve the overall cycle time and productivity. But similarly, IoT applications are also used in dynamically configuring some of the machines. Like we talked about the PLC controllers and how they actually automate the machines and they actually program the machines. You can actually connect that with IoT applications where you can actually sense changes happening in the manufacturing process. You can reconfigure the machine to kind of be ready for a new set of operations, kind of promptly to any other changes that are taking place. So that automatic reconfiguration of machines can actually significantly reduce the typical management latency time where somebody reports this problem, they discuss the problem, and then additions taken. So this all could be automated through IoT applications and hence shrinking the overall cycle time. Of course, safety and compliance. There's so many applications now in industrial context. You could be chemical dangerous gases that could be sensed. It could be you may want to geofence some places. You may want to track people don't get into dangerous locations. And in an emerging context, sometimes you have trucks, your supply trucks, or your outbound logistics. Right? They come part outside your factory. Sometimes they may not follow the discipline like in terms of where exactly they're supposed to park, and that could actually kind of raise the risk of safety as that for not just the manufacturing organization, but also the economy, the society around them. So they can track those trucks. In one application, I know they want to make sure that these truck drivers are disciplined. They actually park the trucks exactly in that location. They use IoT application to make sure that safety norms are followed, not by their own the trucks and the drivers that they own, but actually they may even contract freight operators outside. So they actually kind of enforce the discipline on those freight operators and the trucks that they bring through this IoT application. And so this kind of increasing the visibility can lead to a lot of applications related to safety and compliance. And last but not the least is, as I talked about, we can actually go to customer experience. Now, IoT applications are the starting set of capabilities or technologies that actually can take a manufacturer are closer to what we call as a lot size of 1. If you recall in the introductory section of this series, we talked about the demand from the market is all about because consumers are more informed and they are now demanding what we call as the n equal to 1 sample size of 1 personalization. And we heard from our industry experts and Siemens and other companies that how they are seeing those demands coming from the consumers for personalized experience in the product, and that is coming into the manufacturing operations as what they call as the lot size of 1. Now that lot size of 1 capability is not possible without having some intelligent IoT applications put in place. For example, you could actually kind of put sensors in the products that the customers are using. You can get a lot more information. You can enrich the customer engagement through that, and then better monitor the usage of the product. And that can actually also enable personalization, because not just these passive information that is collected, but you can also have some intelligence on the edge of the products that are being used by the customers. That will increase ability for the manufacturing firm to engage with the customers. Similarly, visibility into macro customer trends, right? For example, what kind of features are being used? What is it that the customers are wanting? In fact, they can these sensors technologies in the customer premises can also help the manufacturers to understand the broader trends in terms of where the customers are interested, what kind of features they're using. Similarly, like as I said, these are just the 5 dimensions I picked. We can go to these IoT applications. In fact, make the manufacturers more green. They are the environmental sustainability of the manufacturing operations can significantly improve by intelligent application of IoT applications, right? For example, they could actually sense any of these hazardous gases leaking. They could actually control the carbon emission that is kind of footprint of that particular manufacturing unit, and they can program and redesign the operations, collecting the right information to make sure that they are not kind of deviating from any norms of the carbon footprint that has been designed for that particular plant, and that's possible. And in fact, we will talk a little bit more later as we go into advanced IoT applications, which enables manufacturers to look at the simulate the implications of the design of the plant, and hence the implications of the carbon footprint in terms of the design decision they take. So IoT applications can also be used in that context, both in terms of design and also real-time monitoring of the carbon footprint in the manufacturing unit.
IoT implementation framework.
As we discussed the enormous business value benefits that are possible from the IoT applications, you may think that it's kind of the business case is no-brainer and manufacturing companies are turning out these applications in numbers very easily. However, that's not the case. Rather, if you look at the success of some of these IoT applications, the initial stages, they're rather mixed. In fact, I find that there are 2 primary reasons for that. First, companies often get overwhelmed with the complex process that is involved in putting these applications together, right? Sometimes they kind of underestimate the complexity. The second, the technology by itself and the connecting pieces could be overwhelming for them, kind of put the change in the organization through this new visibility that comes from these technologies. I believe that companies need a very disciplined approach to how they execute this project. Here, we present a simple 6-step framework for implementing the IoT technology. The first step is to identify the problem area. Companies need to choose the problem that they're trying to solve and the value they're trying to create with the IoT technology. And that choice has to be made in an intelligent way so that it ensures the success of the project. Second, they need to build this capability that is required for IoT applications. It's not about just one project. They need to think this in terms of a set of projects and what are the capabilities and the talent they require, and they need to prepare for that. Third, they need to identify executive sponsors who would be kind of behind these technology and applications, because when you roll these applications, there will be more complexities in terms of the change that they're bringing to the organization, and hence you need that continuous support from an executive sponsor. Fourth, companies need to align the different compatibility needs that are there in terms of the incumbent architecture, the incumbent capabilities that they have before starting these IoT applications. Then in the fifth step, they need to identify the partners that they will bring in this project. If you recall, we talked about the ecosystem of IoT architecture, who are the different kinds of players who come in place. So they need to kind of work and identify the right partners here. And finally, they need to prepare and execute. In other words, as in any other technology application, this requires change management, because you're actually expecting to change the behavior of people who are going to be using this new data. They're going to be looking for opportunity to optimize and improve business process. But unless you have a methodical approach to kind of manage this change, it is not going to happen. So let's start with the first step of identifying the business case. I think it'll be helpful for companies to start with a broad survey of the different problem areas that they're seeing in different units in the manufacturing organization, and so that they can prioritize, identify what are the correct set of problem areas that they want to solve, and then probably prioritize based on feasibility of execution, the business value benefits, etc. The specific problem or the business case that they're actually deciding, they also need to think about scalability as well. Because a lot of times the problem could be kind of particular to one particular unit, and you may want to select a problem where you can do a much bigger impact, because not at the pilot level, you can show it at the pilot in one plant, but then if the problem is such that you can take it to multiple plants, certainly the business value will be much higher. And finally, select the right site, because it also depends upon where you start. You need to have all the support for that particular pilot to be successful. Building capabilities is the second step. Companies need to see this IoT application capability also not as one piecemeal of each project, but they need to understand the set of capabilities that are required, whether it is hardware, whether it is software capabilities, the ability of the talent to understand the real manufacturing challenges and opportunities for improvement. All these things come together. In fact, it may be a good idea to build the set of core capabilities and also think about creating a center for excellence. Because once you have a center of excellence, it is not about just a physical center. It may not be a physical center, it could be a virtual center. But the primary motivation there is then you're now able to pull the learning across different IoT applications into one place, so that you can deploy those learnings into the future applications as well. The center for excellence also allows you to capture different initiatives that are happening across the manufacturing unit, because sometimes the transparency may not exist. Third is the selection of an executive sponsor. It is very important for any of the IoT project initiative to have an executive sponsor, because often these projects, they actually first require cooperation from multiple units. For example, if you're putting rolling out an IoT application, putting sensors in a machine and then proactively tracking the operations of the machine, then you may have to, it's not just about putting the sensor, the technology piece often becomes easier. You also need to prepare your existing workforce for the change, because often it is a social change, it is a mindset change that is required. So you need to think about, and so in order to get all the support, that's why the executive sponsor is very, very important for you to handhold and do this change successfully. And of course, the executive sponsor that you choose has to be knowledgeable and should be a champion of this technology. Then you need to align. Well, this alignment goes in multiple levels. First, you're aligned with the technology infrastructure. Now, depending upon who you are as a manufacturer, you could be an incumbent manufacturer. That means these large manufacturing companies also already have legacy machines. They have machines purchased over many years, right? And those come from different vendors, and there may be some compatibility issues of connecting these machines or putting sensors in the machines. So you need to look at these compatibility and integration challenges. That's where you need to connect this alignment with also the choices that you make in terms of what platforms you will be choosing. Now, when you think about the platform, then the partners that you bring in, then you also think about like what kind of changes are required. Then you have to kind of do some kind of an optimization there because you're weighing the complexity of change that you're enforcing on the existing process and is it feasible or not. And of course, then you have to define how the new process will operate. You could check the new process before you even implementing whether it's kind of viable both from a technology standpoint, from a social standpoint as well. Then, of course, you go back to your partner ecosystems. As we discussed in the infrastructure of IIoT technology architecture, there are so many different partners. There are industry vendors who actually kind of specialize in bringing IIoT platform, an integrated platform that you can use and build your IIoT application, the platform owners. There are, of course, cloud architecture providers that you need to work with them to hyperscale your application once it is successful. You need to deeply understand the devices that you're planning to connect and what kind of restrictions those devices have, and who are the kind of systems integrators or other partners who would have expertise and experience connecting those kinds of devices. And of course, you also need to then put a change management program in place. Remember, this is a bigger change socially than technically. Of course, technology compatibility is a challenge. You need to tackle that working with the right partners. But then those are external partners. You also need to bring internal partners because that's very, very important. In this, IoT applications or any of the Industry 4.0 applications, what I've seen is that one of the biggest disconnect that happens is the disconnect between what I call as the operations technology and the information technology. A lot of times, the information technology, like the ERP systems and the enterprise systems, they're all owned by the CIO office and the IT organization of the manufacturing unit. Whereas a lot of these IoT applications and then embedded intelligence in processes and machines, we call them as operations technology. So you need to bridge this gap well, and that requires making internal partners, like whether it is the IT organizations or it is the shop floor users who are going to be using this, the new application, and they have to kind of be ready to change their behavior, their operations, with the new technology. So hence, you have to kind of prepare for the change management. And so finally, execution. In order to execute successfully, certainly you have to follow up with training I just talked about, right? You got to train for the new change that you're putting in place, and it's both a cultural change and also a technology change. So you need to kind of plan for that. You roll out the pilot project first. You focus on pilot, and then that's how you execute. You roll out the pilot, and also evaluate the outcomes that comes from the pilot. It is important to do the pilot because you often learn a lot in the pilot. You kind of work out the kinks, you see what worked, what didn't, and then you may have to iterate a couple of times for the pilot to work. But once you have the business results in the pilot, then make sure to celebrate that and communicate, because this is more of a social change, it's more of a behavioral change as much as a technology change. I mean, I would like to emphasize that the digital transformation of manufacturing is not just about technology, it is also a cultural transformation of the organization. Hence, it is important to celebrate, recognize the people who contributed, and also recognize the people who are changing their mindset, their way of behavior through these new applications. And finally, once you achieve this, then plan for scaling so that you can take this specific application from this one unit manufacturing unit to more units and more plants so that you can amplify and multiply the business benefits coming from this application. In summary, so this framework talks about the 6 steps of identification of the problem area that you want to solve, building a set of capabilities, maybe through a center of excellence for industrial Internet of Things, and then working with an ecosystem of executive sponsors. Right, you need to get an executive sponsor for each of the project to make sure that particular project is successful, because that requires continuous support, and it requires that that air cover from the management for these projects to be taken off. And of course, you would align with the specific technology needs, incompatibility that you may have, depending upon who you are in terms of the manufacturing industry, whether you're incumbent or a completely new organization. Look at what infrastructure you have and how do you need to align with that, and also look at the external partners that you bring in. That's the next step. Is who are the external partners? What platform are you going to choose? Why are you choosing those platforms? And then what kind of partner network you need to put in place, bringing together your platform providers, your system integrators, your internal partners, your technology IT department, your workers who are going to be impacted, management decision makers who are going to be impacted by this application. Build this ecosystem and make sure they are all convinced, and then start this change management process, very effectively. Finally, the execution, where you're actually kind of putting the pilot in place, showing the proof of concept, showing it working, and you're kind of correcting it to make sure the business value results are out. Then you're communicating and closing the loop. As in any technology applications, the IIoT applications also come with both risks and challenges. There are challenges that companies are likely to face when they think about this opportunity to use IIoT applications in their manufacturing processes, and it also comes with risks. So let's understand both challenges and risks so that as we can build this awareness and make sure that we implement this to ensure success of these applications. Now, the sources of challenges are multiple. I just captured 3 of them here, and then we'll start with first technology compatibility. Right? I mean, as I said, the challenges that companies face from IIoT technology applications, in implementing this depends upon who the manufacturer is. For example, the challenge is going to be different if you're an incumbent company in the manufacturing industry, let's say auto industry, and you've been in the industry for many years, and then you're trying to kind of transform with IoT applications. The challenges you face is going to be different from challenges faced by maybe a new entrant into the manufacturing, auto parts or auto products, say for example Tesla, because the new organization actually have the advantage of starting with a clean slate. They will have probably new machines, they have right interfaces, they have the kind of power to make those decisions while thinking about those IoT applications, right? Whereas an incumbent companies may not have that choice. They already are having a legacy, technology architecture and then machines that are from multiple vendors, so they need to find how to work across these compatibility challenges. And that doesn't mean that it's not possible. In fact, a lot of times, I'll come to the risk piece, because sometimes companies think it is very overwhelming and they don't, get a start at all. And that's not how to operate this. But to understand these challenges coming from these compatibility issues and then manage those. The second challenge that often comes is the variety of devices. Again, you may want to scope, as I talked about in the implementation framework, you have to scope the IoT applications initially to kind of limit the kind of both the variety and the volume of the devices, because both these actually bring complexity to the application, and the variety of devices, of course, certainly increases the business value, the potential of what the application could do. But even if you want to include a lot of variety, then you may want to do it in a phased manner so that you ensure success. The third and a very important piece of the challenge that we see in these projects or in these initiatives is the sourcing of the right talent. Manufacturing organizations traditionally have not thought about talent in this way as it is required in either IoT or other Industry 4.0 applications, because a lot of times manufacturing organizations look at an engineering skill or maybe process management skill, supply chain skill. That's how they've looked at. But more and more of these in IoT applications, or any other technology that we'll talk about in the series, you need a talent pool that comes from multiple disciplines. You need a problem solving team that pulls together engineering talent, pulls together business talent, HR talent, and of course problem solving in the operation process context. You need to put all these things together, and then overlay on top of that, of course, the software ability to kind of to kind of develop the software and execute the software projects, and of course connectivity between hardware and software, the core technology knowledge. That's also important. So companies have to kind of understand this challenge and then think in terms of how do they form the team. In fact, I talked about the Center for Excellence in the earlier segment, because that's very important. You cannot assume that your current existing workforce are completely aware of this change that is needed, and neither can you kind of discard the current workforce, because you have to work with the current workforce. You have to reskill them. You have to identify the new talent that is required, and then you can combine and form these teams. Those are the kind of sources of IoT challenges. There are many more. I just captured 3 of them here. Now let's go to risks. Again, there are multiple risks that you could see in the IoT projects. First, actually, I'll start with cost. A lot of times, cost can be risk on both sides. Right? Sometimes, companies actually kind of are too overwhelmed by the complexity of the project, and they think that it's too expensive and never, get a start. That's one side of the risk in cost. The other side, and that risk, they actually lose the opportunity, right? And that comes with these applications. The other side of this cost risk is sometimes, they're not scoped well. These projects actually can kind of keep expanding, and then, that can actually lead to cost overrun. That's one risk. Cybersecurity is a very important risk. The next risk is cybersecurity, because, remember that you are exposing the data through these applications, and it is important to contain that through the right, cybersecurity software, right, management and governance principles for cybersecurity, and all those have become very, very important to mitigate that risk. Ability to absorb it. What I really mean by that is that, I refer to this in the implementation framework as well, because you understand that companies need to kind of recognize this is not a technology change. This is a social and behavioral change as well. And this is a change to solve a business problem. A lot of times companies may actually get overwhelmed by the quality and the quantity of data coming from these applications, but they may a little bit fall short in terms of how that data or information is used for effective decision making, right? I mean, kind of actionable insights that I talk about, in the framework. So that is missing. So it is important for, for the real value and the benefit to come up is to ensure that the business processes and the decision making processes are changing, and you're realizing the business value to kind of bring it back. And for that, the last piece of the risk is so important, because leadership and change management risk is very kind of connected with the previous one about ability to absorb data, because that behavioral change has to first start with at the top of the organization. The executive sponsors and the leaders of the manufacturing organization need to be kind of completely bought into this, and they have to give a lot of support for this to take off. Because what I've seen, or in my experience, is that once these applications they catch the momentum, when the organization starts seeing the benefits from these applications, then it just kind of starts rolling on its own, and then you get the momentum, and then the culture starts changing with the organization. For that, it is important both from the leadership standpoint and the change management process that is put together to ensure the success. It's about communication, it's about recognition, it's about kind of taking the entire team along as a participatory team, so that as collective success is announced. Kathleen, can you share with us, based on your rich experience in this field, what are some of the challenges that your customers face when they try to roll out this technology? In other words, where do things go wrong? What is it that they should be careful about? And also, what are the embedded risks that are involved in rolling out an IoT technology in a factory?
That's a great question. What are the challenges and risks when you're building an IoT solution or an IoT platform? It seems simple when you first start talking about it, but the more deeper you get into the problem, the more complexities that you face. The first challenge is that every device is going to look different, and they all communicate on different protocols. And so that becomes your first challenge, just figuring out how to talk to each of the devices and how to collect data from them when they all literally speak different languages. In addition to that, a lot of these devices, they don't have a lot of compute power. So you have to be able to get them to connect and share data, and they might just be, a very, very small processor. They might be an industrial PC. They might be a microcontroller. It is a very diverse world, and that is the first challenge that you have to face. The second challenge is how do you collect data from those devices, authenticate those devices, and securely transfer data to whatever point your internet is, whether it's a cloud, whether it's an on-premise system. There's usually a central point where you're having your devices connect to. So doing that securely is very, very important, because you're dealing with potentially sensitive information, sensitive data. So getting your security right is key. Another aspect is how do you process the data in real time with a disparate set of devices that are all connecting with different sample rates and at different speeds and different velocities, and making sure that you have a robust, scalable system, because you want to be able to make decisions on that data stream. You may want to make decisions in real time, and those decisions might be critical to your business. So you never want to lose any data, and you want to make sure that the latency between the time that you collect the data point and the time you can act upon the information that the data points give you, you need that latency as small as possible. So diversity in your devices, in your data systems, in your communication protocols, security, and doing this all in real time without losing any data, and making sure your systems are scalable and resilient. Those are the keys to really getting it right. And there are so many technologies and so many complexities that it really is important to understand your use case, understand the constraints on your problem, understand the limits you need to have in place, so that you can address all of these different challenges for your different business cases.
IoT with okay, we will do it at this key.
Based on your experience, as TCS, working with so many clients over decades on these applications, if I ask you to pick, which are the 2 major challenges or risks that you see that companies often face based on your experience?
Sure. Yeah. So yes, I mean, while we do talk about the adoption of these technologies, within the manufacturing context, we do have a lot of challenges, and at times this challenges becomes actually the reason for those not scaling up. Is this IoT initiative within manufacturing not scaling up? First, I would say is the the very reason why this technology is being applied to a certain challenge, right? So let me take an example. By that, what I mean is we have to identify a specific manufacturing or a business problem statement that can be solved with this technology, right? Typically, it so happens that there is a technology and let's see how it can be applied. I would say it has to be the other way around. There has to be a specific business or manufacturing challenge that should be looked at as a candidate that can be solved through this technology. And again, I mean, in our approach as well, the way we approach this is we try to understand what is that particular problem. This could be related to reliability of the asset. This could be related to improving the yield or soft sensing the yield for a process. It could be improving the throughput from a line, right? So it could be various different challenge that we're trying to solve. So first thing I would say is identification of the problem statement that can be solved through this technology. It has to be that we clearly understand what are we trying to solve. That's one. Second is creating a value or deriving the value that solving that problem will deliver to the business. That is equally important, right? So we have to see how much of an impact this application of technology will do to that specific problem statement. So this being the first challenge. Second challenge I see is with many of our customers, it has kind of led only to a pilot implementation or a proof of concept kind of thing. It has not scaled out beyond one plant or one pilot case.
Why do you think that is the case?
That is the case because again, either we are trying to solve something which doesn't have that much of a business impact, right? So we strongly believe that the impact has to be there not just for that plant, right? So the value comes when we multiply that across multiple sites, multiple lines, multiple factories, right? That's where the cumulative value gets realized, right? So the second challenge I would say is many of the initiatives are still stuck at the pilot levels. Either the business is not seeing a value with the pilot. This is one of the cases that we have seen that we have done a pilot which is very successful, right? Successful in the sense it has the technology has been proven, right, for that particular use case or that particular challenge, but the business is not seeing a value, right, in that particular capability, right? So that's something kind of reduces it to a one plant or one pilot case. The second being not factored the architecture in a scalable way, right? So we have proven it here. Now we have to scale it to multiple sites, right? And that's where again the aspects of conceiving a reference architecture that can equally apply to the variations that exist across the plant, the variation that exist across the underlying IT and operational technologies that are there in the plant. So that would be the second challenge I would say, not factoring those in conceiving an architecture which can be
Very good. Thanks. So basically, I mean, you summarized it very well in terms of the business case issue, right? I mean, clarity of the problem that's being solved and the business value behind it, right? I mean, the first is the case. The second is having the foresight to make sure that the scalability in terms of infrastructure is kind of affordable and scalable. So those are the two places where they have the challenge. So, Sachin, do you want to answer? Do you want to add anything to that?
Yeah, I think that's a very practical question that we are trying to address here. And one of the notions that the operators form during a IoT program is they feel that this program is for reducing manpower, right? Which gives you resistance from them to implement a solution and to effect the changes that you want to do. Now, which is not so. So the notion of reducing manpower through an IoT program is totally wrong. The objective of an IoT program is to gain productivity benefits by empowering the workforce with additional intelligence, right? So it is very important that we are empathetic while embarking on such a program. And the design of the program and the solution has to be extremely human-centric. It cannot be. It has to be human in the loop while designing the entire solution.
That's a very good point. Thank you for sharing that. Yeah,
Lean management becomes extremely critical in this kind of programs.
Okay. So please do this device later.